Okay, now we are at the final part of this video, an implementation of the heap data structure. We can implement a specific type of sorting, HeapSort, that is the sexiest sorting algorithm, but not the fastest actually. It depends, obviously, but quicksort is better for if it is implemented in the right way. But okay, this is the sexiest. And so HeapSort is quite easy at this point. It applies the swap extract fix function or mean extraction function n times, where n is the length of the array we need to order. The worst case scenario is n log n. Okay, so for a moment, let's say you are given this unordered array. Okay, let's say that magically someone turns this into a minip. So we are going to copy this minip and we will see later how we do obtain. Okay, thank you. Some technical problem here. Oh, here it is. So, okay. So let's say that magically you obtain this minip. This is the minip version of the left unordered array. So we are ignoring the first part of the code. We jump this and we have the if. So given this, it is not hard to for you now that you know the minip to order this array. Simply, what do you do? You apply SEX function. So you extract the minimum. You do this 1, 5, you shorten the wall, you put 1 into a new array, and then you use epify. So epify, what do you do? You do the thing with the triangles. Okay, so this. So no, you don't need to swap. Okay, and then what do? You swap the minimum with the last element. So here we have 2, here we have 7, and then you take 2 and add it here. Okay, and then you have this 7 and you swap it. Here you have 3, here you have 7, then you swap it with 4, and then you keep going. Then you will swap 6 with 3, 3, 6, wall, 3, etc. until you exhausted all the array. So you will write 1, 2, 3, 4, 5, 6, 7, etc. Okay, so this is given a minip how the order works. And you know that extract min costs logarithmic time, so you do it n times, so n times log n complexity. The other function is the build heap function, that as long as build heap is less or equal n log n, the complexity will be n log n, and build heap is less or equal than n log n. It is actually less, but that is hard to see. We are not going to see it now. It is needed for another algorithm, another day. But yeah, build heap, trust me, is less or equal than n log n. Okay, so how do we convert the 7, 6, 5, 4, 3, 2, 1, the most unordered array you can see, into a minip version, that is the right version we had at the beginning. Okay, into this version. How do we do this? Okay, let's see the real example, that's better. So here we are converting, we start from 7, 6, 5, 4, 3, 2, 1, 3 like structure. We apply 3 EPFIs, one EPFI here, one here, and one here. So the first EPFI gets applied, and 5 get swapped with 1. Okay, and then you obtain the second data structure. Then the second EPFI gets applied, and we swap 6 with 3, and we get to the third tree-like data structure. Then the third EPFI gets applied, and we swap 7 and 1. And then we keep going with the EPFI, because 7 is not the smallest in the new triangle, and we swap 2 and 7. And finally, okay, now I made it. We get to this situation, and this is the array relative to the last 3 structures. So you can obtain, given a completely unordered array, you can obtain in O, that means less that n log n. I don't use theta this time, but I don't need to explain this right now, but it is, of course, it is O. O of n log n, you obtain the minip version of the unordered array. And as you have seen earlier, from the minip version, we can, in n log n time, obtain the ordered array.